Okay, so hopefully these first four look pretty familiar. Okay, the first one that we're going to do is letter A, and we're going to solve it by substitution. Letter B, we will solve by elimination. Hopefully those words sound familiar. So if I am solving this first one by substitution, what does that mean that I have to do? Plug something in, right? So that means I need to solve one of these equations for either x or y, and then plug it into the other one. So again, there's not really a right or a wrong. There's just usually an easier option. I would choose the second equation here, and I would solve for either x or y. It doesn't matter. Which one do you guys want to solve for? Y. Okay, if I solve for y, I get x plus 3, correct? Okay, now that this is x plus 3, this is equal to y. I'm going to take this, and I'm going to substitute this in where I see y in my first equation, okay? So I've got 3x plus 2 times x plus 3 is equal to 11, okay? This is, again, just Algebra 1 stuff at this point. We've got to distribute here and solve for x. So I'm going to let you guys go ahead and finish that, and we should end up getting x to be 1. So finish solving that, get your variable for x, and then try plugging that back in to solve for y, okay? My x is 1, so that means that when I plug it in up here, I get y equals 1 plus 3, which means y equals 4. Now, your previous Algebra and Algebra 2 teachers, I'm sure, have told you a million times that when we write our solution, how do I write my answer for this systems of equations? You forgot. What is it? As an ordered pair, right? This is your solution, 1, 4, okay? This system of equations that we are solving tells me that I have two lines, right? And they intersect at one point, and that one point is 1, 4, okay? If I were to graph this, that is where they would intersect, okay? Questions on substitution? Okay. Letter B, solve by elimination. Elimination means I'm getting rid of a variable by adding my equations together. Can I add these equations together and get rid of a variable right now? No. So I need to multiply each equation by a number. Okay, if I multiply this, well, first of all, we have to decide. Do we want to get rid of x or y? It doesn't matter. Pick your favorite. X. Let's get rid of x. If I want to get rid of x, what do I need to multiply this first equation by so that it's the opposite of this bottom one? I heard someone say it too. I agree. Then that gives me 6 on top, right? What do I need to multiply the bottom equation by to get the opposite of 6?
3.
Opposite of 6.
Oh, negative.
Negative 3. Okay? Depending on who taught you elimination, they might have taught you to subtract. Okay? That is okay as long as you are subtracting correctly. I like to add the equations together so that way I don't mess up with the subtracting of negatives. Okay? So I got to distribute this here. I've got 6x minus 8y equals 2. Negative 6x minus 9y equals negative 36. Okay, so I can add these together here. X's go away. And now, see, this is where it would get confusing if you're subtracting, because a lot of people forget that if I am subtracting here, I would have negative 8 minus a negative 9, right? It's just easier if you change it all to adding. So that way we don't have negatives next to each other. So this gives me negative 17y is equal to negative 34, which means y equals what? 2. Okay, I've got y equals a number. Now when I need to solve for x, I'm going to go back to my original equations, and I'm going to plug in y equals 2 to solve for x. It doesn't matter which equation you use. I usually just pick my favorite, which is usually the one with less negatives. So I'm personally going to choose the second equation here. And I'm going to plug in 2 for y. And I solve it. And I get x to equal 3. Okay, but again, if you left this as your answer on your little mini quiz or on your test, I would take off a half a point because I need to write this as a coordinate. This would be 3, 2 for your final answer. Okay. Now, before we move on to the next example, I want to show you guys a way that you can check your work on your calculator. Okay. So grab your calculator out. We're going to talk through what buttons that you need to click. Oh, I have one on my desk here.
Oh,
Yeah, I'd get one of these. Okay, so you might want to write this down on your notes as well so you don't forget. But the first thing that you are going to click is your apps button. Okay, you select apps, and then you are going to select the same option of Poly Smelt 2. And then we've been using the polynomial root finder, poly root finder. That one tells us how to solve for what? If I plugged in an equation underneath the polyroot finder, that solves quadratics, right? So solves quadratics. But what we want is option 2. It says simultaneous equation solver. This one, just as it sounds, solves equations. Okay, so we are selecting option 2. And then once you select option 2, it shows you things like equations, unknowns, and those are really the only 2 things that you are ever going to change. Okay? Under equations, it goes from 2 all the way up to 10. For unknowns, it goes from 2 all the way up to 10. Okay, so we're gonna plug in example B. So that means we're gonna choose 2 equations with 2 unknowns, right? Because I've got 2 equations with an x and a y in each one. So select 2 on both of those, and then you will hit next, which is actually your graph button. And then yours is either going to look like this, where you have a blank with x plus blank with y equals blank, and all of those have zeros actually in front of them, unless someone else had typed something in prior. Or you're going to have like a weird matrix thing where it just has blanks, blanks with a line and a blank. Okay? This is the same thing. So you're going to plug in whatever your coefficient for x is in the first equation in this box or in this box. And then you're going to hit enter. Okay? So you hit enter after each time in order to get your equation to move over. Okay? So you're plugging in these values from example 2, or example B, and you should, after you plug it all in and hit solve, it should give you the answer of x equals 3 and y equals 2. Okay, so try it out on your calculator. Let me know if it's not working for you. Okay, let's look at letter C and D. These are kind of special cases in terms of systems of equations. If I was solving letter C, I didn't care how you did it. Systems of equations, you can do substitution or elimination. What would you probably choose here? Elimination, right? Because I can multiply the second equation here by 2, and if I do that, I get negative 8x plus 2y is equal to 4. And if I add these 2 equations together, I have my x's go away, I have my y's go away, and I have the equation on the other side go away. So I'm left with 0 equals 0. Is that true? Yes, it is. So that means what?
All real numbers.
All real numbers. So infinitely many solutions or all real numbers is your answer for this one. Okay. What does this mean graphically if I were to graph both of these lines? It would go forever, yes. They would not quite intersect because that would just be 1 point. Yeah, they're the exact same line. It's like I have a line here, but then my other line that it was given to us is just exactly on top of each other. Okay, so I have 2 lines. They look a little different, but they actually are the same exact line when you graph them. Okay, so that's why all real numbers work for this system. Okay. However, letter D, if I were to solve this one, what could I multiply the equations by in order to get rid of some variables? Top one by 2. This gives me a positive 6x minus 4y equals 8, which means if I add these together, I have x's that go away, y's that go away, but then I have 0 equals 15. Not in this world, it doesn't. So that is not true, which means what? No solution. what does that mean in terms of what our lines look like? They don't ever intersect, which means they are parallel lines. So they actually have the same slope. If I would rewrite this in slope-intercept form, we would see that our slopes are the exact same. Okay? Awesome. Okay, all of those you've seen now for 2 years, okay, in Algebra and Algebra 2. Now, examples E and F, I don't believe you guys have done in Algebra 2. However, you still solve them the same kind of way, okay? Now, we're looking at a quadratic, and we're looking at a linear term, okay? What that means is if I have a quadratic, let's think about this. If I were to graph a quadratic, a parabola, okay, something like that, and I had a line, we're going to intersect that graph how many times? Twice, right? Is that always going to be the case? No, when is it not going to be the case? What do you mean if it goes the other way? If it's vertical, what if it's, yeah, it could be anywhere vertical. If I go vertical here, right, it's only going to cross once. Is there another time when it's only going to cross once? Yeah, Will?
Horizontal, but like, gotta go like, I don't know how to explain it.
Exactly right there. It touches that one point. Yeah, that's exactly right.
Could there be another one that can go diagonally? You could start.
Oh, yes. You could have a tangent line. So I could have like a point here it touches, but it's only tangent to that point. Yeah, that totally works also. Okay. So we're either going to have one or two solutions, okay, for these. So when I'm solving, there's, again, always an easier way to do it, but you can do it multiple ways, okay? So I'm going to kind of show you some options here of maybe which one you might see first, and then maybe which one might be a little bit easier to do. So if you were looking at this systems of equations, what would you guys think we should do? What's an idea that we could to solve this? I hear get rid of the y's, and I hear multiply by 3x. By negative 3x. Let's think about it. If I multiply by negative 3x, that's going to get rid of the x squared, but then I'm going to have like an xy, and I don't think that's going to work out too well for us. Okay, so I can't quite do that. We can totally solve and get rid of the y's. Another option that sometimes people do, and there will be one like this on your homework that you'll have to solve, is we can do substitution here. Okay, if I solve this second equation for x, I would get negative 3y minus 4, right? Now, this is the part that's not super fun because this whole thing is going to replace x, which means we would have to do this whole thing squared and distribute and all that fun stuff and then simplify it, okay? That will work. However, the easier way to do this one would be to get rid of the x's, or not the x's, to get rid of the y's, okay? So this is an option. You can do this if you want, but you don't have to, okay? Let's go ahead and get rid of my x's, or my y's instead. So what do I need to multiply the top equation by to get rid of my y's? 3. And the bottom equation by? It's already negative up top, so I'm just going to multiply by 2 instead, okay? So I distribute here, and I get 9x squared minus 6y is equal to 15. And 2x plus 6y is equal to negative 8. Now, just be careful when we are adding things together here, because 9x squared plus 2x, is that 11x squared? No. It cannot be combined, right? So I just need to write it as 9x squared plus 2x. What happens with my y's? Cancels out. And then I'm left with, on the other side, positive 7. Okay? I've got a squared term, which means I'm probably going to do what? Factor. So I'm going to get this equal to 0. Okay? Now, we've done the quadratic formula already in algebra and algebra 2, okay? So when you get to this point, if you would like to factor, you can. However, we've all got this thing in front of us that can save us a bunch of time, yeah? And we can plug it in and find out what x equals on our calculator, okay? So this time you're not choosing option number 2 on the polysmelt function. You're choosing option number 1 to solve for your quadratic, okay? So plug in your calculator. And solve for x. You should get 2 answers.
Oh.
7/9 and -1. So plug that in your calculator. Make sure you also get the same thing of 7/9 and -1. Okay, I've got my x's. Am I just done now?
Yes.
No, we have to have an ordered pair, right? So I need to solve for y. Now, again, it doesn't matter which one you plug it into. If I were you, I would obviously not choose the quadratic. I would choose the linear thing, but that is up to you. So I'm plugging this back in to the original equation to solve for y. Let's start with -1. That'll be a little easier. -1 plus 3y is equal to -4. So I get 3y is equal to -3, and y equals -1. So I have one coordinate, -1, -1. Now the other one, 7/9, is not a nice decimal because it's repeating itself, right? So we're going to change the denominator and make it into a fraction answer. So this was a little grosser, but it's okay. We can do it. We've got 7/9 plus 3y is equal to -4. And if I'm solving this, I'm going to subtract that 7/9 over. So I've got 3y is equal to -4 minus 7/9. Now, can I make -4 have a denominator of 9? Yes. It would make it -36/9, right? Minus 7/9. Kind of look like A's. Those are supposed to be 9s. Okay, so then I've got 3y equals -36 minus 7, -43, divided by 9. And then to undo that, multiplying by 3, divide by 3. And if I divide by 3, that's the same thing as multiplying by 1/3, right? So this gives me y equals -43 divided by 27. What a gross fraction there. So your final answer would be 7/9, comma, -43 27. This next one has all 4 quadratic terms. I've got x squared, y squareds, 2x squareds, and y squareds in the second equation. However, if I look at these 2 equations, what could I do? I could just start to get rid of them, right? Because look at my y's. Those are opposites of each other, right? So if I add these together, I have how many x squareds? 3. My y's are going to simplify out. And then I have 12 on the other side. That's pretty nice. So I get x squared equals 4, which means x is going to equal what? Not just 2, plus or minus 2. Okay, so I'm going to have 2 solutions. I'm going to have 2 comma something and -2 comma something. Okay, to figure out what that other something is, we can choose whichever equation we want. Plug it back in. I'm going to choose the first one here. So I'm going to choose 2 squared plus y squared equals 4. Well, what would have to be y there in order for that to be true? 0, right? What if I made this a -2? Technically, -2 when I plug it in, it's in parentheses. So y would also be 0. So your 2 answers are 2 comma 0 and -2 comma 0. Okay. Now, problems like this with quadratics, we cannot plug into our calculator like we did for the system of equations to solve it and check it. Okay. There might be a way, but I'm not sure what it is. So maybe I'll look it up, but I don't know how to do it right now. So yes, question. Okay, then we're going to skip up to example A on the second page. We're not going to do word problems today because of the weird schedule. I didn't have all of my third period here, so I didn't want to move on completely. So it's a little bit of a lighter day today. We are solving a system with 3 variables, okay? Now, this is something that you can plug in on the calculator, and it will solve it for you, so you can double check your work, okay? Now, this example takes some time, which is why there's only 1 of them on here, but there's like 4 on your homework, I think, so you need, actually there might be only 3. Make sure you try them out, okay, because watching me do one is not the same thing as you trying it yourself, okay? So, the main thing here is that I want you to choose your favorite variable and get rid of it, okay? If I look at these 3 equations here, again, there's always one that's a little easier than the other normally. So if I'm looking at these equations, what would you maybe think your favorite variable would be here?
Z.
I heard Y, I heard Z. Those are both good answers because Y has a 1 in front of it for both of them. But I like Z even better because it has a negative and a positive. So when I add those 2 things together, that's going to get rid of it, right? If I were going to add these 2 equations together, I would have to multiply one of them by a negative to get rid of the Y, right? Or you could subtract the equations, okay? There's a lot of ways that you can do this stuff. So I'm going to go ahead and add these 2 equations together. And when I add these 2 equations together, I get 3x plus 2y, and my z's go away, and that equals 4. Okay, so I have one equation. I have one new equation, okay? I need to do something with this top equation, and I need to choose another one of these 2 equations to get rid of the same variable, okay? Again, it doesn't necessarily matter which one. There's one that might be easier than the other. Personally, excuse me, I would choose this one here. Because what can I multiply that second equation by in order for it to be the opposite of 6, z? 6, right? So let's multiply this equation by 6, okay? I'm going to rewrite these equations off to the side here. So I'm going to rewrite the first equation. And then that second equation I'm multiplying by 6. So I'm going to have 12x plus 6y minus 6z equals 12. Okay, so my z's, they're gone. I've got 15 x's, 15 y's, and I've got 15 on the other side. Okay, so now I have these 2 new equations that I got by combining 2 equations from my original 3 to get these 2 new ones, okay? So now that I have equations of just x's and y's, I can go ahead and solve this system of equations. Okay, if I'm solving this system of equations, what am I going to multiply that top equation in blue by? Negative 5. To give me negative 15x minus 10y equals negative 20.
So you're taking that.
We can go ahead and add these 2 things together. When I add them together, what variable goes away? The x. The x is gone. I'm left with 5y is equal to negative 5, which means that y equals negative 1. Since I have 3 variables here, instead of a coordinate pair with only 2 numbers, we're going to have a coordinate pair with 3 numbers, and it's going to be alphabetical order x, y, z, okay? So now that I know what y equals, I had these original 2 equations here with my stars after I've added it that just have x and y. So can I plug negative 1 back into one of those and solve for x? You bet I can. So let's do it. I'm plugging negative 1 back in. I'm just going to plug it back into that equation. So I've got 3x plus 2 times negative 1 equals 4. Which gives us 2. We do have to find z. So I found x, I found y. To find z, we need to plug both of these things back into one of my original 3 equations. It doesn't matter which one you choose. Again, there's usually an easier one to choose than the other, but plug it back into the original. So which one do we want to use? The last one. So I'm going to plug in x plus y plus z equals 2. I'm going to plug in all my values. So I've got 2 plus a negative 1 plus z equals 2, which means z equals 1. So our solution as a coordinate is 2, comma, negative 1, comma, 1. Okay. It is a 3-dimensional graph. So there are 3 points instead of 2. Okay? Now again, I'm just going to kind of go back and just make sure we're all on the same page here with where I got this stuff from. You start out by choosing whatever your favorite variable is, whatever you want to get rid of first, right? So I saw that these z's were opposites of each other already. So I was like, I'm going to add these 2 equations together. Okay? Then I was like, well, I got to get rid of the z's from the top equation as well so that I can have 2 equations to solve for x and y. So that means I have to take this top equation and multiply it or add it with either of these bottom 2 equations. Again, it doesn't matter which one you choose, but multiply that out, get rid of your z's, and now we had 2 equations with x and y. We solved that system of equations for x and y, and then we plug it all back into the original equation to solve for our missing variable. Okay? Questions on that? Looks pretty doable? Maybe so? Okay, I think you guys are capable of it. All right, so on your homework, you're going to do everything on that worksheet except for the word problems. We'll save those until next class. So that's, let me go look at, I think it's like problems, yeah, I don't actually know. Let me go look, and I'll change it on Schoology as well so it reflects correctly.